This LOS is describe types and characteristics of residential mortgage-backed securities, including mortgage pass-through securities and collateralized mortgage obligations, and explain the cash flows and risks for each type. Residential mortgage-backed securities. In the United States, there are three sectors for securities backed by residential mortgages. One, those guaranteed by a federal agency, Ginnie Mae, whose securities are backed by the full faith and credit of the U.S. government. Those guaranteed by a GSE, for example, Fannie Mae and Freddie Mac, that's a government-sponsored entity, but not by the U.S. government. And three, those issued by private entities that are not guaranteed by a federal agency or a government-sponsored entity. The first two sectors are referred to as agency residential mortgage-backed securities, RMBS, and the third sector as non-agency RMBS. Mortgage pass-through securities. A mortgage pass-through security is created when one or more holders of mortgages form a pool of mortgages and sell shares or participation certificates in the pool. The cash flow of a mortgage pass-through security depends on the cash flow of the underlying pool of mortgages and consists of monthly mortgage payments representing interest, the scheduled repayment of principal, and any prepayments net of servicing and other administrative fees. A mortgage pass-through security's coupon rate is called the pass-through rate. The pass-through rate is lower than the mortgage rate on the underlying pool of mortgages by an amount equal to the servicing and other administration fees. The pass-through rate that the investor receives is said to be net interest or net coupon. Not all of the mortgages that are included in a pool of securitized mortgages have the same mortgage rate and the same maturity. Consequently, for each mortgage pass-through security, a weighted average coupon rate and a weighted average maturity rate are determined. The weighted average coupon rate is calculated by weighting the mortgage rate of each mortgage in the pool by the percentage of the outstanding mortgage balance relative to the outstanding amount of all the mortgages in the pool. And there's an example that we'll look at in the text. It's just simply a weighted average calculation. It's easy. Similarly, the weighted average maturity is calculated by weighting the remaining number of months to maturity of each mortgage in the pool by the outstanding mortgage balance relative to the outstanding amount of all the mortgages in the pool. So we'll just take a second to look at that example in the text right now, but it's just a weighted average. It's easy to calculate the weighted average coupon rate and the weighted average maturity. So here's just a quick example. You can see example 6, the weighted average coupon rate and weighted average maturity. So assume that a pool includes 3 mortgages. So you can see mortgage 1, mortgage 2, mortgage 3, outstanding mortgage balance 1,000, 3,000, and 6,000. So you add the 3 together, that's going to give you a total pool of 10,000. So you can see the first mortgage is 1 over 10, that's 10%, 3 over 10, 30%, and 6 over 10, 60%. So they made the percentages really easy so you can understand how these calculations are done. So the coupon rate on mortgage 1, 5.1%, mortgage 2, 5.7%, mortgage 3, 5.3. So how do you do the weighted average coupon? 10% times 5.1% plus 30% times 5.7 plus 60% times the 5.3, and you get a weighted average coupon 5.4%. As I said, really easy to calculate. And in terms of the number of months to maturity, you can see the 3 mortgages are different. Mortgage 1, 34 months, mortgage 2, 76 months, mortgage 3, 88 months. So again, you do the weighted average months is just 10% times the 34 plus the 30% times the 76 plus the 60% times the 88, and you get 79 months for the WAM. Easy. So I'll just do a quick practice question. For a mortgage pass-through security, which of the following risks most likely increases as interest rates decline? A, balloon, B, extension, or C, contraction? The correct answer is C. When interest rates decline, a mortgage pass-through security is subject to contraction risk. Contraction risk is the risk that when interest rates decline, actual prepayments will be higher than forecasted because borrowers will refinance at now available lower rates. Thus, a security backed by mortgages will have a shorter maturity than was anticipated when the security was purchased. Part of this LOS is explain the cash flows and the risks for each type, but don't worry, the next learning outcome statement is also define prepayment risk and describe the prepayment risk of mortgage-backed securities. So there's a little bit of overlap here, in my opinion, with these two learning outcome statements. Nevertheless, when we're looking at residential mortgage-backed securities, we can talk about prepayment risk. And an investor who owns mortgage pass-through securities does not know what the future cash flows will be, because these future cash flows depend on actual prepayments. And prepayment risk includes two components: contraction risk and extension risk. Contraction risk is the risk that when interest rates decline, the security will have a shorter maturity than was anticipated at the time of the purchase, because homeowners will refinance at the new lower interest rates. Extension risk is the risk that when interest rates rise, fewer prepayments will occur than what was anticipated at the time of the purchase, because homeowners are reluctant to give up the benefits of a contractual interest rate that now looks low. So we'll just do a quick practice question. The monthly cash flows of a mortgage pass-through security, most likely A, are constant, B, change when interest rates decline, or C, are equal to the cash flows of the underlying pool of mortgages. The correct answer is B. The monthly cash flows of a mortgage pass-through security depend on the cash flows of the underlying pool of mortgages, but their amount and timing cannot be known with certainty because of prepayments. When interest rates decline, borrowers are likely to prepay all or part of their outstanding mortgage balance, which will affect the monthly cash flows of their mortgage pass-through security. Remember that the fees related to servicing and guaranteeing the mortgages reduce the monthly cash flows of a mortgage pass-through security relative to those of the underlying pool of mortgages. Now we're going to move on to collateralized mortgage obligations. When the cash flows of mortgage-related products are redistributed to various tranches, the resulting securities are called collateralized mortgage obligations, CMOs. The mortgage-related products from which the cash flows are obtained are considered the collateral. Note that in contrast to a mortgage pass-through security, the collateral is not a pool of mortgages, but a mortgage pass-through security. In fact, in practice, the collateral is usually a pool of mortgage pass-through securities, hence the reason market participants sometimes use the term collateral and mortgage pass-through securities interchangeably. The creation of a CMO cannot eliminate or change prepayment risk. It can only distribute the various forms of this risk among different bond classes. The CMO's major financial innovation is that securities can be created to closely satisfy the asset liability needs of institutional investors, thereby broadening the appeal of mortgage-backed products. The most common types of CMO tranches are 1. Sequential pay tranches. The rule for the monthly distribution of the principal repayments, scheduled principal repayment plus prepayments to the tranches in this structure, is as follows. First, distribute all principal payments to tranche number 1 until the principal balance for tranche number 1 is 0. After tranche number 1 is paid off, distribute all principal payments to tranche 2 until the principal balance for tranche 2 is 0, and so on. Number 2, planned amortization class PAC tranches. A common structure in CMOs is to include planned amortization class PAC tranches, which offer greater predictability of the cash flows as long as the prepayment rate is within a specified band over the collateral's life. Moving on to support tranches. Remember that the creation of a mortgage-backed security, whether it is a mortgage pass-through or a CMO, cannot make prepayment risk disappear. So where does the reduction of prepayment risk, both extension risk and contraction risk, that PAC tranches offer investors come from? The answer is that it comes from the existence of non-PAC tranches called support tranches or companion tranches. The structure of the CMO makes the support tranches absorb prepayment risk first. Because PAC tranches have limited but not complete protection against extension risk and contraction risk, they are said to provide two-sided prepayment protection. Okay? Floating rate tranches. Often there is demand for tranches that have a floating rate. Although the collateral pays a fixed rate, it is possible to create a tranche with a floating rate. This is done by constructing a floater and an inverse floater combination from any of the fixed rate tranches in the CMO structure. Because the floating rate tranche pays a higher rate when interest rates go up, and the inverse floater pays a lower rate when interest rates go up, they offset each other. Thus, a fixed rate tranche can be used to satisfy the demand for a floating rate tranche. So we'll just finish this LOS with two quick practice questions. The first one, the variability in the average life of the PAC tranche of a CMO relative to the average life of the mortgage pass-through securities from which the CMO is created is A, lower, B, the same, or C, higher. A is correct. The purpose of creating different bond classes in a CMO is to provide a risk-return profile that is more suitable than the risk-return profile of the mortgage pass-through securities from which the CMO is created. The PAC tranche has considerably less variability in average life than the mortgage pass-through securities. In contrast, the support tranche has more variability in average life than the mortgage pass-through securities. And the last practice question to finish this LOS, the investment that is most suitable for an investor who is willing and able to accept significant prepayment risk is A, a mortgage pass-through security, B, the support tranche of a collateralized mortgage obligation, or C, the inverse floating rate tranche of a collateralized mortgage obligation. And the correct answer is B. The investment that is most suitable to an investor who is willing and able to accept significant prepayment risk is the support tranche of a CMO. Because the PAC tranche has a stable average life and prepayment rates within the PAC band, all prepayment risk is absorbed by the support tranche for prepayment rates within the band. Even at rates outside the PAC band, prepayment risk is first absorbed by the support tranche. Investors will be compensated for bearing prepayment risk in the sense that if properly priced, the support tranche will have a higher expected rate of return than the PAC tranche. And that's the last slide for this LOS. Thank you.